special dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. To the world where we glide, from the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate.
Hello everyone, my name is Devanjan Askar, and today I will update you about what I have been doing in this past week in my robotic simulation Liquid Galaxy project. So I added some interactable objects in my gazebo environment. I'll just open and show you. Yeah, so this is my environment, and as you can see, these are some objects. With correct amount of control, you can pick this block from here and place it in this empty box. So this is what I have done, and I have also added a camera here. This is ultra wide camera. It does not look like a camera, but it actually is. And the way we can see is, what I have done is I have taken this camera feed. Okay, I will just show you how it looks. So you can see this is how the ultra wide camera looks in one view. And what I've done is, right now I will chop this up in 5 pieces and then stream it to different ports in my IP, and you can see those in different browsers and have an idea how it would look in the Liquid Galaxy. So this is where my Python script is, and I'll just run my Python script. Yeah, it is running right now. I'll just take this URL. Sorry. Okay. So next I'll go to my browser, and yeah, so let me simulate a Liquid Galaxy type of setup here. As I do it, you will see I'm doing it right now with 3 browser windows because 5 will be too many for my screen size. So what I will do is I will just open my streams in here. Yeah, so this is how it would look in the Liquid Galaxy, right? Looks very good to me. And I can also go in here and type controller. Yeah, so here is my controller, and with this I will try to control it. Okay, so one thing I will have to do is bridge, open ROS bridge for connection, and I will connect and then rotate this shoulder. Yeah, so this is how it would look. Thank you. This has been my work in Liquid Galaxy for this past week in GSoC 2025. Thank you, everyone.
Hello, I'm Javier Mancho, and I'm presenting the work done in the fourth week of the Google Summer of Code 2025 with Liquid Galaxy. This week was a bit sorted because I had some personal issues. But I've been working on the Fetch Robot service on the client and the server side. Well, starting with the client, I have generated a robot entity which is based on the information of the robot. Then the robot component will build the information of each robot, and lastly, the robot's model will display the information of every robot available in the system. So as we can see here is the modal in which we can select for example, the robot 6. Once we have selected the robot 6, the Liquid Galaxy will display the information of this robot and will teleport us to the location of the robot. And to do so, I have implemented the fetch robot service endpoint, in which I am returning the information of the robot, of the a list of the information of the available robots, and then combined with the display information in which I am sending the ID of the robot. I will build a single object of the Liquid Galaxy, then display the information using the method that I done in the first week, and navigate to the location. For the following weeks, I will be working on the LLM by doing some fine tuning using the rovers domain. Um, and yeah, that's it. Thank you for hearing me. See you.
Hey everyone, I am excited to share a significant update on my project this week. I am pleased to report that I have successfully completed the LG rig integration. More importantly, my project is now successfully running and fully operational on LG rig. I have been deliberately testing it, finding an operational issue, fixing them in real time, and continuously improving the performance and stability. Additionally, a key achievement this week was being successfully implemented and generated of dynamic command. I have also been testing this command, finding an edge case, fixing any bug, and improving their robustness. Overall, it has been a very productive week, and I am thrilled with the progress I have made on this integration through my hands-on effort in testing, finding, fixing, and more improving. So let's I show a demo to you. So I will be operating the command from the this controller. So I'm taking it to the main screen of mine, but you will see the LG running on the my project running on the LG rig. So let's start. I will be adding a plane. You can see that the plane has been adding in uh, in the rig, and after that the command is being generated. So yeah, and I use the TTC text to speech of Google API by default for now. So this was for now up to here, and if wrong exit, it will show a wrong exit error over here. So I'm finding the bug and making it more improvement from now onwards. Thank you.
Hello, this is vlog for third week of GSoC. I was not able to do much work because I was outside this week, but I am back now and I pushed some changes yesterday. So this week I added the tools page. I improved the UI a bit, and now everything is working with the app, and the KMLs are getting sent to the Liquid Galaxy, and the app is able to show the visualization on the Liquid Galaxy. Thank you.
So, hello everyone, myself Jayavardhan Shukla, and I am working on the project Open Building Data Visualization, which basically shows the building footprints which are obtained from the data source from the Google Earth, and displays it in the Liquid Galaxy. So basically, this video is about my progress over the first week of the GSoC 2025. So in this week, I have worked upon the mobile application part. The UI is almost 80% ready, and the features of the mobile app are working. For instance, I can search a particular location. Let's say, so we can basically search and select a particular bounding box for the location. The bounding box would obtain the coordinates in terms of starting and ending latitudes and the starting and ending longitudes, and would send these coordinates to the API. So I have also created an API which basically would obtain the Google obtain the necessary KML file from the Google Earth. So this is the one. We can see that we have to give the minimum latitude, minimum longitude, and maximum latitude here. So we would be supplying this from the application and would obtain a particular KML file. This KML file can then be visualized in the Google Earth to basically see all the bounding boxes in 2D as well as 3D. So I have also created a 3D bounding box layout, a KML template which can be used for showing the 3D buildings in this dataset. So here it is. This kind of bounding box, for instance, if the building selected is this particular the Statue of Liberty, then this bounding box would be created all around it, so that it would be separated from the rest of the buildings which would be available there. This would be showcased in both street view as well as in the normal 3D visualization, so we would be able to visualize 3D buildings from there. For 2D buildings, we can show it directly as a 2D label footprint across the boundary of the building, and the color of the footprint would be dependent on the confidence score of the building. So this is the progress till now. I am working future in this next week. I would be completing the mobile application part, and would also be starting to visualize this and seeing the results in the Liquid Galaxy. So this would be the task for my next week. Thank you very much.
Hi everyone, this is Sanya. I am doing a project catastrophe visualizer. So this is me telling about my week one progress. So on the day one, I did API research and planning, and finalizing the API. Like I would be using USGS for earthquake, GDACS for global disasters, and understanding a bit about KML, studying the Google Earth format and place marks and stuffs. And on the day two, decided to do the project architecture. So how my files are gonna be look like. So I divided into three format: model, services, providers, and stuff. And setting next, I focused on setting up the pubs dependency in the pubsx.yml. And then third day was about API integration, building the HTTP services for fetching the real-time disaster data. And then also the next day was about KML generation, implementing the KML generation from disaster objects, adding color coding for different severity levels and disaster types, uh, and checking the outputs in the Google Earth. And the next day was about state management. So it was about implementing disaster provider for state management, creating a liquid galaxies service with SSH simulation. So it was giving a mock simulation kind of stuff. And then I stayed and connected the API and KML services together. Next, it was about making a bit about the UI, created a list how the disaster events will be viewed, and I added loading and success indicators, and also the error ones, and functionally testing the interfaces. And then it was about checking the build issues which I was facing with the current version of Gradle I was in. So changing that and the package conflicts and stuff, and then again keep on testing, end-to-end testing for the emulator in the real device, and creating the demo materials and the progress remote. That was all about week one. Thank you.
And this is my week for update of the GSoC project, Eco Explorer for Liquid Galaxy. As I have completed all the user interfaces in the first 3 weeks of the project, it was now my turn to work on the part in which we actually show things on our Liquid Galaxy rig. So as of now, first of all, I created the basic, established the basic SSH connection in which we connect to the Liquid Galaxy server, which was successful. Along with this, I also tested a basic KML which I developed previously during my tasks, which was also successful. It showed the things clearly in my all three screens. And then my next part of work was to provide the basic commands like shutdown, reboot, and then relaunch. The Liquid Galaxy commands, which were present in the past projects of Liquid Galaxy. So I compiled them and tested them on our rig, in my local rig, which was also pretty successful. And as of now, I have started working on the KMLs. I worked with an orbit controller, so I created a controller to orbit around a specific location, uh, which is basic, which will be common to every forest. And then I'm working on the KML in which I will be creating the fire landmarks which are fetched from the NASA Forms API. So there are few images that I have uploaded to GitHub. So I will fetch the images of those link and show them on the Liquid Galaxy rig, showing which are of three types: low, high, and medium, which will be judged by the various parameters provided by the NASA Firm's API data. After that, I will provide the option to show a map view in our application in which we can click on each individual point or each individual location where fire has occurred and zoom into that location. That zoomed in fire will be represented using another polygon which I will be developing by the end of the week using Perlin noise generator. So that's it for week 4. Thank you very much.
Hello, I'm Alejandro, and this is my fourth week in GSoC. This week, I've installed ROS into the Docker server. I've included some images also into the server, which we can see here. And I've sent these images to the app, and they can be sent to the Liquid Galaxy. Let me show you how this works. The data in the application is still being simulated because ROS is just installed, but it's not working. As you can see here, we have ROS and we have the new RGB camera images and the class that we've created, which is here. And if we log in into the app with the IP of the Liquid Galaxy and the username and the password, we can see also a new design in the home screen. And if we connect to the server, we can see that the RGB camera now charge loads here the image that is in the server right now. we can send this image to the liquid galaxy by clicking on start streaming, and if we click on RGB camera only, it sends the image and it's being shown here. This is all for this week. Thank you very much and see you on the next one.
To a world you can see through panoramic screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate from data to display.